So we're told in this question that we want the branch cut to be along the positive real axis. And we're asked to show that there's a sudden jump in the value of the square root between these two values. So to evaluate the square root, we write these in polar form. Remember, we only want to find an approximate value. This is just to illustrate the jump, not to find it exactly. So 1 plus I epsilon is in polar form approximately, well, the length of this, the modulus of this is approximately 1. And the angle here, well, if we worked out exactly, it would be inverse tan of epsilon. But inverse tan of epsilon is approximately epsilon. So we've just got e to the I epsilon. Okay, that's good enough. Approximately equal to. Now, when we take the square root, we're asked to find the principal branch. So it's a positive square root. So the square root of this is simply 1 plus I epsilon. Square root of this is simply we just divide this by 2. Divide the exponent by 2. And what's this equal to? Well, it's well, when epsilon is small, this is approximately e to the naught is approximately 1. Right, now for this one, this is where we have to be careful, and this is the key to the question. When we write this in polar form, how do we do it? Well, obviously the length is still 1, but what's the angle? Well, the angle is not minus this, because we've got a branch cut here, we have to measure the angle right round here. So the angles are between 0 and 2 pi, which means the angle we want here is 2 pi minus epsilon. Okay, it's not minus epsilon, it has to be between 0 and 2 pi, which means that the square root of this is half this, so it's e to the I pi. Okay, I'll split it into 2 bits, minus e to the minus epsilon. E to the I pi, of course, is minus 1, and this is approximately 1, so we get the answer approximately minus 1. So there's a big jump between approximately 1 and minus 1.